Okay, so we are starting with Apache Kafka. Apache Kafka was designed by LinkedIn and it was open sourced in 2011 to Apache. So let's see how the data transfer happens between a source and a destination. Let's say I am having a source. Let's say for that case, my source is Twitter. I want to download some data from Twitter or I want to continuously get some data from Twitter. And let's say I want to get that data in my Hadoop cluster. Let's say my client is Hadoop. So in this case, this is the way how the data will be transferred, and it is called as a data pipeline. Okay. Someone, if it is not mute, can you mute? Yeah, Rahul, can you mute, please?
Sure, just a second.
Thank you. Okay. So we were starting with Apache Kafka, and we said that Apache Kafka was developed by LinkedIn, and in 2011 it was open source to Apache. For downloading a data, let's say this is my source and this is my destination or a client. Let's say for that case, my source is Twitter and my client is Hadoop cluster. And there will be a data pipeline and data will flow from source to the client. Let's say for that case, if I am having multiple clients, this is my source that is Twitter, and I am having multiple clients. Let's say this is my first client, client one. Let's say this is my Hadoop cluster. Let's say this is my some other system. It can be Hadoop or it can be something else as well. Let's say for weblog analysis, I'm using some system. Maybe it is a MySQL or Oracle, or for that case, it can be any other system. Let's say there is one more client, client 3. So in this case, there is only a single source that is Twitter, and there are multiple clients. Let's say Hadoop, some other client for weblog analysis, and something else, or some other system for analyzing the logs of Twitter or something else. Or maybe it is the same data that is coming and it will be analyzed by multiple clients. So this is how the data pipeline will look like. Let's say we go to a more complex case wherein there are multiple sources. Let's say there are multiple source and multiple clients. So let's say we draw again the previous one. This was my client 1. This is my client 2. And this is my client 3. And now there are two sources. Let's say my source 1 and source 2. Let's say my source 1 is again Twitter, and let's say my source 2 is something news website or something else, or it can be Facebook or something else from which the data is coming. So the data pipeline will look something like this. Source 1 is getting connected to client 1, client 2, and client 3. Source 2 is getting connected again to client 1, client 2, and client 3. So you can see over here that you can see on this side it is so much messy, as well as multiple connections are established. So I will say there are multiple connection, and it also affects the bandwidth. It negatively affects the bandwidth. It is taking away a lot of bandwidth that results in slower data transfer, more request coming on source 1 and source 2. It takes a lot of bandwidth over here as well as here. So to go away with this problem, to go away with this messy issues, because this number of sources can go on increasing over here as well as number of clients can go on increasing over here, that will make it even more messy. To go away with this mess, the solution to this is Apache Kafka. To go away with this issue, the solution is to get to use Apache Kafka if there is a multiple connection. So how this Apache Kafka helps is, let us see in the next slide. Let's say there are multiple sources. Let's say there are multiple sources. Let's say this is my source 1, this is my source 2, this is my source 3, this is my source 4. There are multiple sources and there are multiple clients. Let's say client 1, client 2, client 3, client 4. These sources can be anything. It can be a Twitter, it can be Facebook, it can be news website or something else, some other website or whatever is generating a data. It can be some sensors that are from IoT. So all these things are generating continuous data. And this client can be a Hadoop cluster. It can be a standalone Spark cluster or standalone Spark installation using Mesos, or it can be some other system that is processing this data. It can be my MySQL system, it can be a Oracle system, and so on. It can be anything for that case. So to get this data in between, instead of this messy connections, instead of having a messy connection like this, instead of having so much messy connections, instead of getting all these messy connections, what we do is we use Apache Kafka to avoid all this mess. So let's see how it will look. Let's remove this messy connections. So instead of all this messy connection, there will be a simple solution or a single solution, that will be Apache Kafka. So all these things, all these sources will send the data to Kafka. All these sources will send the data to Kafka. And from Kafka, the data will go to each of the client. So instead of multiple connections happening, now there is a centralized thing, that is Apache Kafka, and the data will come to this Kafka and it will finally go to each of the client. So this was my Twitter, this was my Facebook, this was my news website, and this was something IoT sensors. Now in terms of Kafka, just pay attention to all these terminologies that I am using, because all these terminologies are very important for interview point of view. These sources will be called as producers. So your simple question can be in interview, what is producer? So all these sources will be called as producer. The separate installation, that is of Kafka, is called as a broker. Kafka will be called as a broker. All the nodes in which the Kafka is installed, all the computers in which the Kafka is installed, is called as brokers. And whoever is subscribing to this broker's topic, whoever is subscribing to this messages, is called as a consumer. So just pay attention to all this terminologies. So this, my source will be called as a producer, this will be called as a broker, and this will be called as a consumer. The data will flow through Kafka, and from Kafka, the data will come to the client. This Kafka is nothing but a distributed message queue. It is nothing but a distributed message queue. Apache Kafka is a distributed message queue. It is installed as a separate cluster. So let's say there will be 3 machines or 4 machines that will have this Apache Kafka installed. So it is installed as a separate cluster. So first thing is Kafka is a distributed message queue. Second thing is it is installed as a separate cluster of machine, and each of these machine on which the Kafka is installed, it is called as a broker. Each of this machine on which the Kafka is installed is called as a broker. Each of this machine will be called as a broker. If you are having any doubts, you stop me in middle and you can ask me the questions. So till now we discussed that there is a source 1, source 2, source 3, source 4. They are sending the data to Kafka. From Kafka, the data is going to the client. Client can be Hadoop, separate Spark installation with Mesos, or it is a MySQL server, or it is a Oracle, or something else. This will be called as a consumer. This will be called as a producer, and the Kafka installation will be called as a brokers. Kafka is a distributed message queue. It is a message queue which will operate as a first in, first out. The message that comes first will go out first, or however it is reading over here. So it is a message queue. Queue is always first in, first out, and it is installed as a separate cluster. Let's say I am installing on 4 machines, and this is my cluster. And each of this machine will be called as a broker. Let's go ahead. For using this, for using this Kafka, we create something called as a topic. So first step will be to create a topic. Create topic. Second thing is the producer, that is, this is my producer, which is a Twitter, Facebook, or all these things. These will be pushing the data to the topic. So second thing is producer pushes data to topic. And the third thing is consumer or the client, this is my consumer or the client, will subscribe to the topic. Consumer subscribes to topic. So these are the 3 simple steps. The step 1 is to create a topic. Step 2 is producer will push the data to the topic. Producer will be pushing the data to the topic, and this consumer will subscribe to the topic to get the data. Anyone, any doubts in this?
Hi Harish, I
Yeah.
have one question.
Yeah, yes, yeah.
Uh, if you are installing Kafka on different cluster, do we need to install Kafka on producer side or consumer side? Do we need to install that?
On the producer side, we can, it is usually integrated with some other thing, like it is integrated with Scoop, or it is integrated with Flume.
Okay, we are just connecting to outsource to Kafka, right?
Yeah, we are just connecting through Kafka.
It's like this JDBC connection to MySQL.
Yes,
Okay.
yes, something like that. Yes. Okay. Anyone, any other doubts? Okay. If no doubts, we'll go ahead. So this Kafka is a publish subscribe messaging system. Kafka is a publish subscribe messaging system. That is, the producer will be publishing, and client or the consumer will be subscribing to that. Producer, if as we saw in the previous slide, this producer will be publishing the data and the consumer will subscribe the data. So it is called as a publish subscribe messaging system. It is fast, it is scalable. You can add the more number of machines in a cluster, and it is also durable. How it is durable, we'll see in some time. So it is fast, scalable, and durable. We'll see in some time how it becomes fast, why it is scalable, and why it is durable. Few of the companies that use Apache Kafka are few of the companies that use Apache Kafka are LinkedIn. Of course, LinkedIn only made, so it is using always. LinkedIn has 400 node cluster for Kafka itself. So there are 400 computers or 400 PCs or 400 machines connected in parallel that forms the cluster for Apache Kafka. It is having 18,000 topics. They transmit around 3.2 million messages per second. 3.2 million messages per second. So this is the huge amount of data or messages that are being transmitted per second. And this is very old. In fact, when they give the publication, maybe around 5 or 6 years old, this data is 5 or 6 year olds. Now if you see it, it may be more than 400 nodes clusters. Other companies that uses this is Netflix, Twitter, Airbnb, Mozilla, Uber, and lot of many small companies, like even I know a few of the companies like NG Data. They are having their own tool called as Lily, and they are using Apache Kafka for data transfer and so on. So many companies use Apache Kafka, and Apache Kafka is even the hot favorite topic for the interviews as well. Moreover, the code for Apache Kafka is itself written in Scala language with some part of Java as well, but majorly it is written in Kafka, Scala programming language. Now, to make it fast as well as reliable or durable, as we said, it is fast and durable. Let's see why it is fast and why or how it is fast and how it is durable. To make it fast, the Apache Kafka uses a concept that is called as partitioning, partitions. And to make it durable or reliable, it follows a concept that is replication. So while you are creating, as we saw in the previous slide, that there were three steps. First step was to create the topic. The second step was producer will push the data to topic. Producer, that is Twitter or Facebook, will push the data to topic, and the third step was the client or client will subscribe to the topic to get the data. So these are the three steps. While you create the topic, while you create the topic, you can specify the number of partitions and replications. For example, LinkedIn uses the number of replication as 2, and partition can differ. Similarly, replication also can differ. So whenever you create a topic, you specify the number of partitions and number of replications. So what happens because of replication means it is the number of places where the same data will be stored. Like when we studied Hadoop, we saw that replication factor was 3. That is, the same data is at least stored at 3 times. So by default, the replication factor was 3. That means the same data is stored at least at 3 other nodes. Similarly, in case of Kafka as well, there is a replication. Let's say the replication factor is of 2. That means the same data will be stored at least 2 nodes or 2 brokers. Now we call it as a broker. So when we say replication is at 2, that means the same data will be stored at 2 different places. Let's say it is present over here as well as it is present over here. So even if one of the broker fails or one of the machine goes down in the cluster, the data is still present in second broker. So this is the reason using a replication we make it as a reliable or durable. So Kafka uses a replication to make the system reliable or durable, so that even if one of the broker goes down, we can bring up the another broker and it is also having the data. Second thing is partitioning. Let's say I am creating a topic. What I will do is I will make multiple partitions. What I will do is I will make multiple partition. Let's say my partition 1 is over here. This is my partition 2, partition 3 and partition 4. So when I'm pushing the data from producer, I will push some data in partition 1 and I will push some data in partition 2. So what a customer can do, let's say this is my custom consumer, slip of tongue. Let's say this is my consumer. What consumer can do, one first consumer can get the data from this partition, another consumer can get the data from this partition. So by doing this way, it increases the parallelism. It increases parallelism. So we are discussing two things over here. The first thing that we are discussing is why it is durable and reliable. We say it is durable as well as reliable because it is having a replication. While creating a topic, we specify that replication factor is, let's say, 2. Then in that case, the same data will be present in first broker as well as second broker. So even if one of the broker goes down or one of the machine in the cluster goes down, the data is still present in another broker. And similarly, what we say is, since there are partition, there is first partition and second partition over here. One of the consumer can subscribe to this partition and another consumer can subscribe to this partition. By doing this way, we can increase the parallelism. As we increase the parallelism, it becomes more fast. So it is fast as well as reliable and durable. Anyone having any doubts till now?
Harish, I have one question.
Yeah,
So you told like we are going to partition the data, right? So if
right,
there is a one file, so like suppose let's file gets divided into two parts, file one and file two, and there are different clients, right? So if you this consumer is a client, right? So which is
right.
going to subscribe to this particular event, right? Whatever we have produced,
Topic,
the post the
yes.
data, right? Topic, right?
Yeah,
So, but how can we ensure that because at the end client needs the full data, right? The file, the complete
right,
file.
right.
So, but in this case, in order to increase the parallelism, we have partitioned the file into two parts, file one and file two. And the client one is getting is getting file one, the partition one, and another one is getting partition two. At the end, client needs the full data, right? So this is not the full data that client is getting.
Not necessary that client will need us full data. Let's take an example. This is
Mm-hmm.
my MySQL application. The first consumer is a MySQL application, and another consumer is, let's say, some Oracle application.
Okay.
Now, this MySQL application requires some other data
Okay.
for its analysis, and the Oracle application is doing some different kind of analysis. It requires some other
Mm-hmm.
kind of data or some other
Mm-hmm.
subset of data. So in that case, it won't be needing the same data. But if it needs the same data, yes, if it needs the same data, it will have to push the same data at both the places.
Okay. So depending upon the client, we need to partition the things, right?
Yeah,
That's
depending
what it
on
is.
client, we'll partition the things, and once the client is or consumer is subscribing to that topic, the client will say, I want to read from partition 1. This client will say, I want to read from partition 2.
Okay.
So while the consumer is reading, it will specify what topic it wants to read. Second thing,
Uh-huh.
it will specify which partition it wants to read. And third thing, it will
Okay.
specify what is the offset from which it wants to read. That is how much it has already read and from where it wants to read. So that is called as a offset. So we'll discuss
Okay. The
this as
client.
we go ahead.
Okay. The client needs to mention this, right?
Yeah, client needs to mention three things. First thing is the topic. Second thing
Uh-huh.
is the partition. And third
Yeah.
thing is the offset.
Okay.
Yeah.
Yeah. Got it. And
Okay.
so this is more in towards like I don't know, I mean, if there is any asynchronous communication kind of thing, right? So it all depends on the messaging, right? So if the it's kind of asynchronous communication, right?
Uh,
In Hadoop,
uh, Asynchronous communication, yes. But if you are
right?
using with the partition
Uh-huh.
and you are reading from a single partition,
Mm-hmm.
Apache Kafka does guarantees the sequence in which the data is flowing. The sequence will be maintained. So it is a
Okay.
asynchronous communication, yes, because there is no clock and all involved. But still,
Exactly.
the sequence in which the data is coming will be always maintained. It won't, the sequence won't go out of the things. Like sequence will always be maintained, provided you are reading from the same partition.
Okay.
Yeah.
Okay. Okay. Thanks,
And
Harish.
okay. Anyone, any other doubts? Okay. If no doubts, then we'll go ahead. Try to understand as much as you can because this Kafka is very hot favorite of in interview. Kafka and Hive, these two are very hot favorite. Let's go to the diagram, how it looks. Let's say this is my Kafka cluster. Let me draw a diagram that has only two brokers. Let's say this is my broker 1, and let's say this is my broker 2. That means when I'm saying broker 1 and broker 2, that means I am having two machines in the cluster. So this cluster is having only two machines. Then let's say this broker 1 is having topic 1. This is my topic 1, and let's say this is my topic 2. And let's say broker 2.
Harish,
Yeah.
sorry to bother you.
Yeah.
So these are the queues, right? Topic one, topic two are the queues, right?
Yes,
You're
these are the
talking.
messaging queues. Yes.
Okay, okay.
Okay. Let's say this is having topic 3, and for using Kafka, there is something called as a zookeeper that is must. We'll see what is zookeeper in some time. Oh, on the left hand side, let's say this is my source. Let's say this is my source. That can be Twitter, Facebook, or something else. We'll talk in terms of Kafka now, so I will call it as a producer. This is my producer again. This is my producer. And on this side is my client. Talking in terms of Kafka, we will be calling it as a consumer. It can be anything. It can be Hadoop. It can be separate Spark installation. It can be some other servers. So this is my consumer. And let's draw the connectivity. Something it is connected like this. So database coming over here. Producer will push the data over here. And consumer will subscribe, and the data will flow like this. Now let's see what's this zookeeper is. Zookeeper usually is part of admin courses if you're running learning admin part, so they need to know it more. For developer perspective, it is transparent, but still we need to know a basic of it. So when you actually install the Kafka, uh, and when you're using multiple systems like multiple brokers, you use this zookeeper for coordination purpose. So zookeeper is used for coordination purpose, so we can call it as a coordination system. As you know, all the namings in big data is on the names of elephants, on the names of animals. Like Hadoop was the name of that elephant toy. Similarly, pig is an elephant. Pig is an animal. Hive is also some animal, and everything is like on the names of some animals. So to manage all this animal, there is a zoo. So it is like Hadoop entire ecosystem is a zoo, and to take care or to coordinate between all the animals, there is something called as a zookeeper. So name comes something like this because all the ecosystem, all the elements in the ecosystem are named after animals. Like Hadoop is the name of elephant, pig, hive, and so on. So this is called as a zookeeper who is going to manage all the animals. So this is another tool, zookeeper, which is again with Apache, and it is nothing but a coordination system that takes care of all the animals in the ecosystem. And for case of in case of Kafka, it stores the metadata. It stores metadata, and metadata includes where the topic is present. Second thing, what are the partitions? What are the partitions? And third thing, like which cluster is having the data. So basically at the back end, you don't have to take care of it. Like you don't have to see what is happening in Zookeeper, but still you should know that this is the Zookeeper that has all the information about where is this topic lying. Like topic 1 is present in this broker, topic 3 is present in this broker. There are how many partitions to it, and each of the partitions are lying in which cluster, like in which broker, and so on. So all this information is called as a metadata, and this metadata is stored in Zookeeper. So Zookeeper is nothing but a coordination framework. So whenever a consumer is getting a data from the Kafka, consumer actually first goes to Zookeeper to check where is the topic, and then Zookeeper informs that here is the topic, and then it connects. But all these things happens behind the scene. It is transparent to the developer. But behind the scenes, all this coordination and all this metadata, behind the scene, it will be coordinated by Zookeeper. So just an introduction about Zookeeper is enough. Zookeeper is a coordination system, and it has all the metadata about where is the topic, where is the partition, and which cluster the data is present, and so on. So for using Apache Kafka, Zookeeper is mandatory. For using Apache Kafka, Zookeeper is mandatory. Even in production frameworks, always you will find that Zookeeper is always present, and it is used for coordination. For Kafka Zookeeper is always mandatory. Okay, any other doubts, anyone?
So is this Zookeeper is more relevant from client or consumer perspective, right?
For producer perspective also.
How so? Because it contains the metadata information, and you told like client is going to tell us which partitions, which topics, and which probably not the cluster he wants to read.
let's
Client
say
wants to read.
let's say producer says that I want to push the data in this topic. Producer don't know where is
Oh,
that
okay,
topic. Is it in first machine or second machine? So producer also needs to go to Zookeeper to check where is that topic.
okay, okay. Yeah.
Okay. So anyone, any other doubts? Okay. So if no doubts, we'll go ahead. So let's see how the broker actually looks like. Let's say this is my broker. So broker will have some messaging queue. Let's say this is my messaging queue, and let's say the messaging queue is this way. So new messages are coming from here, let's say, and the old messages are over here. So these are my messages. So this producer will be pushing the data messages from right hand side. Producer 1, producer 2, producer 3, producer n are pushing the date messages from here, and consumer can take the day messages. Let's say there is a consumer 1 who wants to read from here, there is consumer 2 that wants to read from here, and consumer n wants to read from here. So all these consumers will be reading from somewhere in the message queue. To read, they use something called as an offset. To read, they will be having some offset pointer that will be used to read. Let's say it is reading from the second offset. Let's say this is reading from sixth offset. Let's say this is reading from 10th offset, and so on. So it is reading from some offset position, and it is going on reading. So this is how the data is read, and the data is read using offset. So whenever the consumer wants to read the data, it needs to provide the three things. The first thing it needs to provide is the topic name. So to read the data, or to get the data basically for consumer, it needs to provide the topic name. It needs to provide partition, from which partition it is reading, and third thing it needs to provide is called as a offset. What offset it is reading the data. So this is how the data moves. Similarly, if you are having multiple partitions, so if I want to show multiple partition, I can also show it as a partition 0. There is one more partition. Let's say this is my partition 1, and some consumer is also pushing the data over here. And some consumer group, let's say consumer 3 is taking from this partition. Consumer 7, producer 7 is pushing the data over here, and consumer 3 is taking from this partition. So you can have a partition so to increase the parallelism, and again it will be using some offset. So what consumer 3 will say that it wants to read from the topic, let's say topic name is test. Consumer 3 is want to read from topic test, partition number 1, and offset number, let's say 3. So this is how the consumer 3 will read. Anyone having any doubts can let me know, or else we can go ahead.
So Harish, the blocks that you have created, this is all the topics, right?
This is all the partitions. Let's say the topic is test, and this test is having two partition 0 and partition 1.
Okay.
So this is
Topic
a
is
topic is a test.
queue. Okay. So queue.
It's nothing but a messaging queue, distributed
Yeah.
messaging queue.
Okay. And then we have divided our message into two partitions, that is 0 and 1, right?
Uh, Topic is divided into two partitions, 0 and 1.
Uh, Topic is the queue name, right, Harish?
Yeah, topic is nothing but a queue only, yes.
Right. And then inside the queue, we get the messages, right? It's in probably in XML or JSON, whatever format, right? So we are
Yes.
dividing that particular message into two parts, that is partition 0 and partition 1, right?
Right.
So it's not like topic is the test. I mean, our queue name is test queue, or we can call it as topic. And then we have some incoming messages from the producer, which is divided into two partitions, that is 0 and 1, right? That's what it is.
Incoming message is coming from producer. Let's say all these producers are pushing the data in the partition 0, and these producers are pushing the data into partition 1. So like Twitter, Facebook, some news website is putting the data over here. Some sensor data from IoT, Internet of Things. So all this sensor data from my washing machine, from my cloth dryer, and so on. All these things are coming in this partition.
Okay.
Harish, I have one question.
Yes.
Is it possible to send different sources data into different partitions?
Is it possible to send two?
Suppose Twitter wants to send data to partition only one, W wants to send to partition 2. Is that possible? Or
Yes,
it will
yes. Twitter can send the data to partition 0 as well as partition 1 as well as partition 2. Yes, it can.
only if it wants to send only for partition 1. Is that possible like that?
Yes. When the Twitter is sending, it will say that I want to send the data to which partition. So it's up to Twitter to decide, or up to the producer one to decide it wants to send to which partition. Does it want to send to only partition 1, or does it want to send to partition 1 as well as partition 2?
Okay. For one same topic, we can able to control these partitions, and we can send. Can we able to control offset?
Yes, from consumer we can control the offset. If we want to read randomly, yes, we can control the offset.
Okay, what if we are using only one single partition? How it differs from having multiple partitions?
When we use single partition, uh, it will be only all the, let's say there are multiple consumers and we are using only a single partition. All the consumer will connect to a single partition only. So it will be like all the bandwidth going to the same machine and it will become bit slower. But let's say I am having, let's say for that case, we are taking example of LinkedIn, which is having 400 node cluster. So it is a very big distributed system. So in that case, if I have only a single partition, each consumer is taking the data from a single partition, it will be very slow. All the consumers are coming to a single machine. In the same case, what I can do is, let's say I make 10 partitions. So what I will do is, each let's say there are 10 consumer, each consumer will go to a separate partition. So like the load on a single machine will be distributed to 10 machines, making it faster and parallel processing.
Yeah.
So basically this partition will increase the parallelism, and by that way it will increase the speed.
Harish, can you come again onto this parallelism part? I'm not. So this offset is something like, I mean, let's take one example. Like our producer is CNN news channel, and right. So this there is one message that they are producing on daily basis, like headlines for every day, every morning,
It
right?
will be
So
every, let's say, this is a website or this is a news channel that is
uh-huh.
continuously producing the data. So this data is
Exactly. So
continuously flowing.
yeah, so this offset we are dividing it on like timely manner. Like see, today is first day, so they produce some headlines, the CNN, and then it went into the partition zero, and then again tomorrow morning it again come up with the new headlines, and then it will create a new offset, and then from there onwards it will basically append the new updated headlines. So that's the way it is. The offset concept is into this partition. How we are
What,
defining the offset?
yes, what you're saying is correct. But the thing
Uh-huh.
is, it won't be like today morning and tomorrow morning. It will be a continuous streaming data. That's why we need this uh, Apache Kafka. If the data is coming only today morning and tomorrow morning, then FTP is enough for us.
No, it's on daily basis. Like I mean, it's like
It's
throughout the
like
year or
continuously streaming. Like every minute the data is getting generated. Every second the data is generated. Like the Twitter tweets are coming every second. Every
exactly
second someone is
right.
tweeting. Yes.
So what is the criteria of this offset? Like how we
Okay.
are defining this offset?
Okay. So let's say let's take an example from Twitter. Let's say Twitter is producing some data
Mm-hmm.
continuously, and we have configured that the data that is coming in the messaging queue, so that it doesn't get full. If I don't clear this messaging queue, it will get full. So let's say we have configured that the data that is coming from Twitter will be there in this queue for 10 minutes. So whatever data that is passed last 10 minutes will be automatically flushed. And in this 10 minutes, whatever data that is coming from Twitter, it will go on pushing from this side, from a mouse pointer side. It will be pushed continuously. And the consumer will continuously read the data. That is, it will go on increasing the offset and going on reading the data next. So it is just like a file system that my data is getting pushed from the bottom, and from the top there is someone going to read the data continuously. And after 10 minutes the old data will be always cleared.
So on each and every like subscription of consumer, the new offset gets created automatically. Right after 10 minutes, either the consumer will subscribe to that event or it will flush out and it will create a new offset. Right.
Yeah, offset will go on incrementing, right? As we go ahead, like you have a, let's say you are having a file, a normal
Yeah.
database file in RDBMS. So you have some concept of relative record number. So let's say if you're making a new file, the relative record number starts from 1 and it goes until infinity, like it goes on increasing. So it's like the first data that is coming, it will read, then go on, read the second, read the third, read the fourth. Similarly, the offset will go on increasing.
Yeah, so that I'm just asking about the time when the offset get increased. I mean, it is after 10 minutes. Either it will be the data will when the data will flush out from the queue, or it will listen by the consumer, right? So
Uh,
then
the
it will create a new offset.
So whenever the consumer is reading the data, it will go on
Uh-huh.
increasing to get the next record, right? How will it get the next record?
Yeah, because from the producer itself, it keeps on pushing, right? But
Yeah.
my question is, when the offset get increased?
Offset is going on increasing. Like this is my first offset, second, third, 4, 5, 6, 7, 8, 9, 10, and it is going 11, 12, 13, 14, 15. And this offset is like how the consumer is reading. So it's up to your program to decide how you want to read. You want to continuously read only the second data, or you want to read the third data, fourth data, fifth data, and so on. So it's your program, how you're coding your program to read the data.
Okay. Okay, probably once we'll do the example, then I will make
Yes.
it more clear. I'm
Yes.
not 100% clear with this offset part,
Okay.
like how it is setting the offset at that particular point of time. It came to know that it comes to know that the new offset needs to be get created.
It will be like it will continuously be reading the queue till it goes till it doesn't find any records. I will show you once we do the program, the
Okay,
simple
okay,
one,
yeah.
then it will be more clear probably. Yeah. Okay. So let's go to the next thing, that is replication. So replication is only for fault tolerance. Let's say LinkedIn keeps the replication as 2. That means the same data is present at two different places, that they're having, let's say, 400 node clusters. So this is their entire cluster for Kafka, and the replication factor is of 2. That means the same data will be present in this broker as well as this broker. So even if this broker goes down, it can read from this broker. So this replication factor is only for fault tolerance, and it will only be used when one of the broker goes down. So it is not like Hadoop system. In Hadoop, let's say you are having a replication factor of 3. So let's say the same data is present in this machine, and this machine. So in Hadoop, how it was like, if the hive is over here, so it will read from the nearest machine. So in case of like Hadoop, it was increasing the speed, as well as you can read from different replications. Whatever is near to the client, it will read from there. But in the case of Kafka, this is not the case. In case of Kafka, it will only be used for fault tolerance. Only when this will go down, only when first broker goes down, then only you will have to bring up the second broker, or the zookeeper will automatically bring up the second broker, and it will read from there. So the thing that you need to take care or take note of it over here is, replication factor is only and only for fault tolerance, and it has got nothing to do with the speed, or it cannot read from the second replication factor. It is only for fault tolerance. And moreover, once the data comes to the first broker, it will take some time to replicate to the second broker. So it will never be in sync. It will be a bit slower. And let's say if this system goes down, let's say this is the second broker is slow by 2 seconds, because let's say the data is coming to the first broker and then it is getting replicated to second broker, right? And it is lagging by 2 seconds. So let's say this system goes down and you decide to bring up this system, so there will be a loss of 2 seconds of data. So this is like simple things that you need to understand. Usually, let's say in production, if it goes down, usually it doesn't go down very often because the configuration is good. And even if it goes down, we bring up the same system, if we are able to bring up, so that there is no data loss. Let's say you are not able to bring up this system, you don't have any option, but you want to bring up this one. So there will be a data loss of 2 seconds whenever it got failed, because some data was not replicated over here. So basically, for now, or for learning Kafka, you need to understand that a replication has got nothing to do with parallelism. It is only for fault tolerance, and it is only and only used when one of the broker is down and you want to bring up another broker. Anyone, any doubts in this? Is it clear? Is it very clear?
So Harish, there is no way to handle this the loss of data. I mean, because this is a limitation, right?
Yeah,
We
because
are
replication will take some time, so you cannot handle this 2-second loss of data. If you bring
okay.
up the same machine, the data loss won't happen because the producer is still having the data. Producer was not able to push the data, and this system failed at some time. So once you bring up this data, the data will come flow from producer. But let's say the system fail and you're bringing up this system. So in that case, the producer will push the data now to this one, but there is a loss of this 2 seconds of data. So if you want to recover this 2 seconds of data, then you will have to write a recovery program to get this 2 seconds of data from producer, but it doesn't make any sense. So this two
Yeah.
seconds of data is lost, or whatever is the lagging between the replication is lost. It is very minimal, maybe 1 second or 2 seconds. That's it.
So there is no concept of dead letter queues or something like we have in other JMS like messaging systems in
Okay.
cloud and everything. There is a lot of dead letter queues where we can there's a guarantee of data loss. So we don't have any concept of dead letter queues or anything over here in Kafka.
No, not that, but the data loss in this case is only not happening, right? Because you can still bring up this system back. So whenever
Yeah.
you bring up after 1 hour or 2 hour, there won't be any data loss. But
Okay.
in this case, yes, there will be a data loss. There is no solution to that.
Okay.
Okay, anyone, any other doubts? Okay, so if no doubts, then in second half, what we can do is we can take the break, and time is 11:05 at my place. So whatever geography you are, maybe India or Singapore or US. So just come after 10 minutes. My time is 11:05, so you come at 11:15 my time, US time 11:15 as well, AM, and so on. So just take a break of 10 minutes and come after 10 minutes at 11:15 my time. And after this, you can bring up your virtual machine, and we will be doing Kafka installation because Kafka is not installed over here. If you're using on CloudX Lab like NB is doing, so in that case, Kafka is already installed if you're using CloudX Lab for practicing. But if you're using this Cloudera virtual machine, Kafka is not installed, so we'll be doing installation part of Kafka, as well as we'll be doing a use case for it, a simple use case to ensure that it is working. So come after 10 minutes and bring up the virtual machine meanwhile. We'll take a break and come back. Thank you.